Hello there, this is Miss Nakayama, and I can't tell you how much I'm sorry that I'm not with y'all today. I hope that everybody is well and has a great day, period. I hope to be back tomorrow, without a doubt. So I'm starting off, before I talk about the warm-up exercises, I want to remind y'all that you have a quiz tomorrow, 4.1 to 4.4. It is exactly like your homework problems. Know how to operate with monomials, know how to add, subtract, and multiply polynomials, know how to do long division and synthetic division, and then know how to factor polynomials. If you have any trouble with those, you've got AO, math help during AO 4th and 5th period today and on Thursday before your quiz, and I will be back 7:30 a.m. Thursday morning if you have any last minute questions. Then the graphing calculator portion of your quiz will be on Friday. So without further ado, let's go ahead and continue with our warm-up exercises. So you were supposed to evaluate these polynomials. This particular one when x is equal to -2. So I'm thinking and expecting you to take -2 and plug it in for x. You take it to the 5th power, 4th power, x, and then figure out what you get. But I also want to point out to you what happens if I take that -2 and I take this polynomial, which is 3x to the 5th, -1x to the 4th. There is no x to the 3rd. There is no x squared. There is -5x, and there is 10. And what if I do synthetic division with that? Well, remember we bring down with 3. 2 times 3 is 6. Add, and that gives me a +5. Okay, I messed up. -2 times 3 is -6. That would make that -7 because I was missing that negative sign. -2 times -7 is 14. Add, I get 14. Times -2 is -28. Add, -28 times -2 is 56. And -5 is 51. Times -2 is -102. And you get -92. So I'm hoping you all, when you did your warm-up problem, got the answer. When you took -2, plugged it in there, and you got -92. But let's see if that really works every time. So in this particular polynomial, I would put in 4, and I would have 5x to the 3rd, 1x squared, -4x, and 1. And I'm going to bring down my 5. 5 times 4 is 20. Add. 5 times 21 is 84. I'm going to add. 4 times 80 is 320. And I'm going to add. So you already know the answer because you checked them in Delta Math. So that leads us into what exactly is our lesson today, one of them, and that is something called the remainder theorem. This is 4.5, the remainder and factor theorems. The remainder theorem that we just saw says if you take a polynomial f of x and you divide it by x minus k, that's what we did, we just did it synthetically, the remainder is equal to the value of the function at k. That's what r equals f of k means. So the remainder theorem tells you synthetic division can be used to evaluate polynomial function. Sometimes that's easier. Sometimes it's easier to do synthetic division. So the point of that is to let you know this is also synthetic division, but it is called, when you use synthetic division to evaluate a polynomial, that is also referred to as synthetic substitution. So you just need to be familiar with that because it's not a hard process. I know y'all know that. So let's just make sure you know what the directions are asking you when it does. So look at this one. Use synthetic division to evaluate f of x equals 5x to the 4th plus 2x cubed minus 20x minus 6 when x equals -4. So y'all know I'm going to put -4 out of my little box, and I'm going to go 5x to the 4th, 2x cubed, 0x squared, -20x, -6. I'm going to put my little bar and make sure I have this little box, because what's in that box at the end right here, y'all? is important. We've just established it's the remainder of our polynomial. We already knew it was the remainder, but it also is what we get when we evaluate the polynomial at that point. So this is another thing, y'all. If the directions say use synthetic division, you have to use synthetic division. So remember, we bring down our 5 times 4. Negative 4 is negative 20. Add negative 18. Multiply, I get 72. Add, I get 72. Times negative 4 is negative 288. LL. Add, I get negative 308. Multiply by negative 4, and I get 1232. Add negative 6, and I get 1226. So that tells me that f of negative 4 equals 1226. Okay? And yeah, if you want to, the directions say synthetic division, you would have to show me this work. If it doesn't say, you can go plug in negative 4. But y'all, I keep telling you over and over again, when people plug in negative numbers to evaluate polynomials, they miss it a lot. Okay, now the next concept, you know this. If I divide a number, okay, if I divide any period a number by another number, let's go with, let's just talk about the fact that if I have 12, that wasn't a 12, divided by 4, that's equal to 3. And the remainder is 0. But if I had 15 divided by 4, that would be 3 with a remainder of 3. Well, you need to understand and remember that if the remainder is 0, then we say that 3 is a factor of 12. Okay? Same thing with polynomials. If you take a polynomial and you have a factor, if the remainder is equal to 0, you know it's a factor of the polynomial. So, look at this more closely. Determine whether x, there's two parts to this, x minus 2 is a factor of this polynomial, and b, x plus 5 is a factor of this polynomial. So, you can either go plug it in. I'm going to use synthetic division just because I think it's easier and I like it. So, but you could just go plug in. What do you plug in? Do you plug in 2 or negative 2? That's always the question. So remember, you set the factor equal to 0 and then you solve it. So that means I'm going to plug in x equals 2. My coefficients are 1x squared, 2x, negative 4. All right, then I set it up, bring down my 1, multiply, I get 2, add, I get 4. Multiply, I get 8, add, I get 4. All right, that's in the box is not 0, so that says that x minus 2 is not a factor of the polynomial. All right, let's look at b. So b, x plus 5 is equal to 0, so that means x equals negative 5. That is what I use on my little box. My coefficients of the polynomial I'm dividing, 3x to the 4th, 15x cubed, negative 1x squared, 0x, and 25. Then I'm going to set it up and figure out what I get in this box at the end. Bring down my 3, multiply, add, multiply, add, multiply, add, multiply, add. Ha! I got 0. That means there is no remainder. And if there is no remainder, the remainder is 0, then I know that x plus 5 is a factor of my polynomial. That's as simple as it is. That's how you determine whether or not you have a factor. So look at example 3. Show that x plus 3 is a factor of this polynomial and then factor it completely. That means you have to go as far as you possibly can. And remember, factoring, y'all, is always with integers. It is not, that's kind of really hard to read. Let me come down a little bit on that. Let's go to here. Okay? Factoring always involves integers. It does not involve fractions or decimals. Okay, so keep that in mind. All right, so show that x plus 3 is a factor. That means I'm going to remember x plus 3 would be equal to 0. So x would equal negative 3, and that means negative 3 is what goes in my box. And then I have 1x to the 4th, 3x cubed, 0x squared, negative 1x, and negative 3. Now, it says show that x plus 3 is a factor. Well, that's telling me it's a factor, which means that I know 0 has got to be here, and that has to be 3. And when you start the problem off like that, y'all, it just kind of keeps you in check, and you know that when you start over here and get over there, you better get a 3 right there, or you've done something wrong, because they told me it was a factor. So I'm going to carry down my 1, multiply, add, multiply, add, multiply, add. Negative 3 times negative 1 is positive 3. So I got 0. So remember, all right, so now I've got to go factor this polynomial. So remember, I started with a 4th degree. It always goes down by 1 in synthetic division. So now I have a 3rd degree. And so if I have x, that's going to be x cubed, no x squared, no x, and that's going to be negative 1. So I'm going to have x cubed minus 1. That's what that equals, but you can't remember the first factor that looks like that. So this is what it looks like. I have x plus 3 as a factor, and this is the remaining factor. And as I mentioned to you earlier in these last 2 lessons, in Algebra 2, when you factor, you always have to look and see if you can go further. Can I go further? Can't with this one, but I absolutely can with that. That is the difference of 2 cubes. So how am I going to factor it? I got to carry down my x plus 3. And how do I factor that cube? I take the cube root of x cubed. That's x. I keep the sign the same, minus cube root of 1 is 1. Then I use this linear factor, and I square the first term, which is x squared, change the sign, multiply them together, ignoring the sign because that plus took care of it, and then the last one is always positive squared. Okay? And as I've mentioned to you before, this is always prime. So you know you're done. Okay? You cannot be factored over the set of integers. Okay, last 2 things. Use the graph to find the factors. So here is a graph of this polynomial. So y'all, if you had something like this, it's a little bit further. It's not anything that we've learned how to do, but I could give you a graph like this and have you do this problem. It also could be on the graphing calculator portion. Okay, so just be aware. I'm going to look at this and I'm going to go over to my graph because we know the factors, okay, are related to the roots. So I'm looking at the roots. Here's one root right here. And that number is negative 1.5. And then there's a factor right here, and that is positive 1. And there's one right here, which you could hover over and find out that's going to say 1.3333. And then we have the number 4. So let's go talk about what these are. So first off, this says x equals 1.5. Or no, excuse me, x equals negative 1.5. Okay? And as I just mentioned to you up above, you can't have fractions when you're factoring. So if it's asking me the factors, I got to get rid of this. So first off, I'm going to take negative 1.5 and write it as a fraction. And you all have calculators that will do that for you. So that's x equals negative 3/2. Then to get rid of the fraction, I multiply by the denominator. So I multiply both sides by 2. That gives me 2x minus 3. And then I'm going to set it equal to 0. 2x plus 3 equals 0. And I'm going to stop there and go to the next one, which was 1. X equals 1. X minus 1 equals 0. I didn't want to do that yet. X minus 1 equals 0. Okay? The next one says x equals 1.333333. I'm really hoping y'all know what that is. I don't know if your calculator will do it for you, so some of these you just have to know or you can test them out. But that 0.33333 means x equals 4/3. Get rid of that fraction by multiplying by the denominator. 3x equals 4, so that means 3x minus 4 equals 0. And then the last one says x equals 4, so x minus 4 equals 0. So each of these that I have set equal to 0, right here, this, that. Okay, y'all, I'm just working backwards with my zero product property. So all I have to think about is removing and put parentheses around each of these factors. So my answer is going to be y equals 2x plus 3 times x minus 1 times 3x minus 4 times x minus 4. And that is all the factors, or the factored form of that polynomial. Okay? How technology can make things a little bit easier for you. All right, look at this last problem. Find the roots from the graph. Okay? Sounds like a graphing calculator portion. Where are, I didn't mean to, there's the answer. Okay? But where did we find those answers? Okay? Again, x-intercepts. Y'all already know this. At -8, -4, and -2. And those are the real solutions. In the problem before, we talked about how they're factors also, and what the factor looks like related to the solutions. Okay? Quick reminder, quiz tomorrow. Come get help if you need to. And I look forward to seeing y'all soon. Thank you so much for watching, and y'all have a great day.